802.1X provides port-based authentication. Network devices have the following roles. The Supplicant is an 802.1X compliant software service on endpoints. It communicates with NAD authenticators to request network access. These NAD authenticators control access to the network based on client authentication status. How do clients actually get authenticated? The authentication server role does client authentication as performed by Cisco ISE. It validates client identity and notifies NAD authenticators of client authorization status. You may also have back-end servers for Active Directory and Certificate Authority services. Now, the objective here is for endpoints to authenticate to the authentication server via some extensible authentication protocol, or EAP. NAD authenticators act as an intermediary or proxy between client and authentication server. They communicate with endpoint supplicants via 802.1X to request identity information. The NAD authenticator then relays this information to the authentication server in a radius message. We should zoom in to get a bit more detail about this communication process. Either supplicant or authenticator can initiate authentication. In this example, the supplicant initiates by sending an EAP over LAN or EAPOL start message. The authenticator requests client identity with an EAP request or identity frame, and the supplicant responds with an EAP response or identity frame. Now, here's where the authenticator begins to serve an intermediary role. It harvests the identity information from this 802.1X EAP packet, creates a radius access request, sends it to the Cisco ISE radius server. Some challenge and response frames go back and forth, and if the credentials are correct, the port is authorized. The specific exchange of EAP frames varies based on the authentication method you choose to deploy. The figure is intended to depict the three phases of the 802.1X authentication process: the beginning, the middle, and the end, when the endpoint logs off and the port becomes unauthorized. Now, as a result of successful authentication, Cisco ISE can perform per user or per group authorization. For example, it can associate a VLAN with a particular user or group. The ISE authentication server can also associate an access list or ACL with a particular user or group, named ACLs for wireless users, and downloadable or DACLs for wired users. The NAD dynamically assigns the ACL to the user session, so this gives you very granular access control over your users. Security Group Access, or SGA, gives you a very scalable way to control access. With SGA, ingress switches classify data traffic for a particular role and tag the traffic with security group tags. The egress network devices evaluate these tags and filter packets by applying security group access lists. Let's take a deeper look at VLAN assignment. Every wireless LAN and wired switch port has a default VLAN. However, you can configure the Cisco ISE authentication server to override this for certain users or groups. This dynamic VLAN is configured on the Cisco ISE radius service and communicated in a radius access accept message. For example, suppose a sales associate connects their laptop to a switch. When they authenticate, Cisco ISE recognizes that they are a member of the sales group. Thus, the user is authorized without VLAN override and so is on VLAN 30. However, Cisco ISE recognizes some other users as a member of the sales manager group. Thus, Cisco ISE tells the switch to dynamically override this default VLAN and place this endpoint in VLAN 40. Named ACLs provide differentiated access for wireless users and are configured locally on the WLC, the wireless LAN controller. You merely reference this access list in a Cisco ISE authorization policy, ensuring, of course, that the name you specify in Cisco ISE matches the WLC's actual access list name. That's important. Okay, now when a user requests access, the ISE radius server authenticates and authorizes the user, telling the controller which ACL it should use. The WLC dynamically applies the specified ACL for this user session. So that's a named access list for wireless users. Downloadable ACLs provide differentiated access for 802.1X authenticated wired users and are configured on the Cisco ISE radius server. So, when a user requests access, the radius server authenticates the user and sends the appropriate ACL attributes to the switch. The switch applies these attributes to the port during the user session. The switch removes the per user ACL configuration when the session ends if authentication fails or if a link down condition occurs. The switch does not save radius-specific ACLs in the running configuration. When the port is unauthorized, the switch removes the ACL from the port. Okay, did you notice the big difference between switched DACLs and wireless named ACLs? Remember, named ACLs are configured locally on the WLC, while switched DACLs are configured on the Cisco ISE radius service. Here's a DACL example, which is also an example, by the way, of standard radius server's ability to support so-called vendor-specific attributes, or VSAs. This downloadable ACL VSA is passed to the switch line by line as a result of the authorization process. This DACL represents one possible way to change the authorization level of a user. Change of authorization, or COA, is a standards-based method to change endpoint authorization status, to dynamically modify active sessions. Now, for this discussion, by the way, I might shorten the word authentication to Auth-C and authorization to Auth-Z. Initially, the device is not authenticated. There is a normal ACL configured locally on the switch and applied to the switch port. So this ACL allows very minimal permissions, only that traffic which is absolutely needed to get authenticated. Now, after successful authentication, the endpoint posture remains unknown. Authorization may use a downloadable access list that allows Cisco ISE to perform profiling, security posture, and guest services. Once endpoint posture compliance is verified, Cisco ISE sends a COA message to the Authenticator and supplies extended access privileges. Now, typically, this is a DACL. Cool. Did you see how we went from unauthenticated minimal access to slightly elevated access to full access? That's the power of COA. Static MAC Authentication Bypass, or MAB, uses a MAC address for both the username and the password. This is the most basic form of authentication used for devices that simply do not support 802.1X. But there are some concerns. Because MAC addresses are easily spoofed, they are a relatively weak form of authentication. Even so, they are still a good first step for device identification. So, on the plus side, MAB enhances your visibility into the network. The system can link the device IP and MAC addresses with connected switch and port. Quite useful for security audits, forensics, and troubleshooting. You get identity-based services. All of the 802.1X dynamic authorization techniques also work with MAB, VLAN assignment, ACLs, and SGA. Also, MAB acts at layer 2, allowing you to control network access at the edge. MAB can be deployed as a fallback mechanism for 802.1X. When endpoints connect, the NAT tries to use 802.1X. If there's no response, it tries MAB next. Of course, MAB can also be deployed as a standalone authentication mechanism. And remember the primary use case for MAB. It can authenticate non-802.11 capable devices. Now, this is good stuff, but there are limitations. Remember, network access devices learn the MAC address of endpoints and send this to the radius server as both the username and the password. How does the radius server know whether these MAC addresses are valid? Well, this requires a pre-existing database of acceptable MAC addresses, which you have to create and you have to maintain. Could be a little bit of work. And when used as an 802.1X fallback mechanism, there is delay. MAB waits for IEEE 802.1X to time out before validating the MAC address. These delays can negatively affect endpoint functionality, although mitigation techniques are available. Now remember, MAB only authenticates devices, not users. So different users logged into the same device will have the same network access. And finally, unlike 802.1X, MAB is a fairly weak authentication method and can be defeated by spoofing a valid device's MAC address. Okay, so we understand the benefits and concerns. Let's take a look at how MAB operates. MAB enables port-based access control based on the learned endpoint MAC address. It provides a method to handle 802.1X exceptions. Certain MAC addresses are allowed to skip the regular 802.1X authentication process. Now, initially, endpoint identity is unknown. When the switch receives that first frame from the endpoint, it learns the source MAC address. Now, it doesn't forward this frame nor any subsequent frames because the port is not yet authorized. However, it forwards this MAC address to Cisco ISE as a radius access request message. Assuming that this is a valid MAC address, Cisco ISE sends an access accept message and the port is authorized. The switch uses source MAC address filtering to help ensure that only the MAB authenticated endpoint is allowed to send traffic on this port. Okay, let's look at a scenario where MAB acts as a fallback mechanism to 802.1X. In the initiation phase, the switch detects port link up and initiates authentication by sending an EAP request identity message. If the switch does not receive a response, it retransmits the request. Eventually, 802.1X times out and the switch proceeds on to MAB. In the MAC address learning phase, the switch allows the port to accept a single frame and thus learns the endpoint MAC address. Now, this and all prior frames are discarded. The switch sends a radius access request packet, which includes the endpoint MAC address as 3 separate attribute value pairs, or AVPs. It is used as the username, the password, and the calling station ID. In the authorization phase, the radius server validates the MAC address. If valid, it sends an access accept message. This message informs the switch to allow endpoint port access. The message might also include a dynamic VLAN or DACL. If the MAC address is invalid, an access reject message is sent, and all endpoint frames continue to be dropped. However, if alternative authentication methods are configured, the switch may attempt 802.1X or web authentication or deploy the guest VLAN. In the accounting phase, if the switch successfully applies the authorization policy, it can send a radius accounting request message to the radius server with details about the authorized session.